another number that would work? Okay, there is another number that would work. What would it be? 0. All right, if I plug in 0, 0 times 0 minus 8 would be 0 times negative 8, which does equal 0. So x equals 0. All right, so we've got our answers for 1 and 2. What about 3? Oh, going straight to the difficult ones. Okay, so straight to the difficult ones. Aiden said 3.5. So if I do 2 times 3.5 minus 7 times 3.5 plus 3, 2 times 3.5, what does that equal? 7. And over here I get 6.5. And 7 minus 7 is 0. And 6.5, that gives you 0. Yes, x equals 3.5 will work. And what did you guys say the other one would be? -3. Now, how are you getting this? How are you getting them so quickly? You want one of the factors to equal 0, right? Because if this equals 0, it doesn't matter what the other part is, because 0 times anything equals 0, right? And if this part equals 0, it doesn't matter what the other part is, because anything times 0 equals 0. So this is actually our zero product property. That's the name for that property. You've known it for a long time. You've known it ever since you learned your zero multiplication tables, right? And zeros were probably one of your favorite multiplication tables. When the teacher told you that 0 times anything equals 0, you're like, yes, that's so much easier than the 8s, right? So zero product property is just anything times 0 equals 0. So, you guys went straight to even getting the answer right for this right here, this 3.5. Aiden was really quick on that. Sometimes students have a hard time figuring out what number goes here to make this 0, all right? Because it's not a whole number, obviously. Whenever we just have whole numbers here, it's really easy to see, well, the opposite of positive 3 is negative 3, or the opposite of negative 8 is positive 8, to see those answers that would go there to make that 0. But mathematically, what we can do for this, if we want, or if we need to, on these problems, is we can do 5x equals 0, and we can say 8x plus 9 equals 0. So if we have a piece that's more complicated, one that's harder to figure out off the top of your head, then you can just take each factor and set those each equal to 0. So for the first one, we would need to divide both sides by 5. 0 divided by 5 is still just 0, so 0 would be one of your answers. And on the second one, we would need to subtract 9. So 8x would equal negative 9. And then we would divide both sides by 8. So x would equal negative 9 over 8, which you can just leave as a fraction, will be fine.
As a decimal, it's negative 1.125.
Mm-hmm. Either is fine, but you're probably going to see fractions more often than decimals on the answers. For those. All right, so does that make sense? Anything times 0 is going to be 0. So if your equation is equal to 0, then you just have to figure out which piece needs to be 0. Okay? So these problems were already factored for us, so we could kind of figure that out. But let's look at the others that you're going to see. Okay, so for example 5 here, we've got x squared minus 8x plus 12 equals 0. So if I try to solve this a different way, don't write down what I'm about to write, because what I'm about to do is going to be terribly wrong. What I see students try to do a lot of times is maybe they try to solve this for x by maybe subtracting 12. And that's going to give you x squared minus 8x equals 12. So if you're going to do that, then what would you do next? If I divide it by 8, I technically have to divide everything by 8. So that gives me x squared over 8 minus x equals 12 over 8, which reduces to 3/2. Does that look better? Nah. If I square root everything, this is the square root of x squared over 8 minus x equals the square root of 3/2. This square root is not going to get rid of that square, because, like, if I have the, for example, if I have the square root of 4 plus 9, that equals the square root of 13. It does not equal 2 plus 3, which is 5, right? That would be wrong. So if you have two things that are added or subtracted underneath the square root, you can't, like, take the square root of them separately. So, so that would give me this. That doesn't look good, does it? It just looks like we're making this worse instead of better, all right? So you can, what's going to be key here, on the problems we were doing yesterday, we only had one x. Okay? The problems we were doing yesterday might look something like this. X squared minus 8 plus 12, or equals 12, or something like that. Right? So we just had this single x right here. But our problems today, the issue is they're going to have an x squared and an x. Are x squared and x like terms? Can you combine them? Can you solve for x when you have an x squared and an x in the problem? Anytime you try, like you can move stuff to the other side, it's still not going to work. So, when we see a problem like this, so let's make ourselves a little note over here to the side. If you have an x squared term and an x term, you're going to need to move everything to one side and factor. So this is the reason we have spent so much time factoring. Because a quadratic equation like this, we cannot solve by using normal methods for solving equations. Now, if it looks like the problems we saw yesterday where there's only an x, then we can solve that using our normal methods. We'll just use that square root both sides. It'll work out. But if we have x squared and an x, we're not going to be able to do that. So if we have x squared and an x, we're going to move everything to one side so that it is equal to 0. And then we are going to factor. So in this case, everything is already moved to this side. I've got equal 0. That's the key. You want to have equal 0. If it doesn't equal 0, you got to move stuff, right? So once I've got x squared minus 8x plus 12, I'm going to factor this, which we have done a lot of already, right? So to factor x squared minus 8x plus 12, we would have an x here and an x here. To get a positive 12, what could I multiply together? 6 and 2, or 3 and 4, or 1 and 12. I'm using the negatives of this because I see I have a negative 8 in the middle. Which one of those combinations is going to give us a negative 8? Negative 6 and negative 2. So I put a negative 6 here, negative 2. On this one, because it just has the x's, you should kind of know that that's right. But if you need to, you can check it by doing x squared minus 2x minus 6x plus 12. And that does give you what you started with. So that just checks to make sure it works. So the biggest part of solving these problems is going to be the factoring that you already know how to do. But our answer, that is not our answer, right? When your instructions were just factor, your answer was x minus 6 times x minus 2. But now your instructions are going to be to solve the equation. So what numbers would give us 0 if we plug them in here? 6 and 2, right? So what you're doing here is you're using the 0 product property. Anything times 0 is going to equal 0. So that means if x minus 6 equals 0, the whole thing's going to be 0. And so if you just add that 6 over to the other side, x equals 6. I don't mind if you do that part in your head. It's fine. You don't have to necessarily write down those steps. But I'm going to, just to be real clear what's happening. Over here, if x minus 2 equals 0, it'll make the whole thing 0. So we could add 2 to both sides there. X would equal positive 2. So positive 2 or positive 6 will work for our answer. This is going to be especially important once we start like putting this into context of some different stuff when we start doing our catapults and we do things like that. Right now we're just working on the mechanics of it still, so we're not going to have any context for these problems. Questions on example 5? Alright, example 6 is going to be a little bit different than the last problem. What am I going to have to do first on example 6? Even before I do that, I need to do something else. Everything needs to be on one side. So it is really important to understand that this, what I'm doing right here, only works if it's equal to 0. Because that's the only multiplication tables where the answer is always 0, right? Anything times 0 equals 0. That is not true for 2. Anything times 2 does not equal 2, right? So 0 is the only number that works for. So what we cannot do, and this may not even been what Kaylee was thinking about, you cannot like factor this out, like factor out of 2x, get 3x. Don't write this down because it's terribly wrong. Minus 5. That's the greatest common factor on that left-hand side. It's equal to 4. And then say 2x equals 4 and 3x minus 5 equals 4. That would be terribly wrong. Because you can only do this if it's equal to 0. So first step always needs to be move everything to one side for these problems. If you see an x squared and an x in your problem, move everything to one side. So we're going to take this 4 over here, we're going to subtract it so that it'll go over here to the other side. So 6x squared minus 10x minus 4 equals 0. And right there is where the magic is at, having the equals 0 right there. If you don't have it equal to 0, you're not going to be able to factor it and solve it. So we need everything on one side first. Now we can look for a greatest common factor. In fact, it'll be helpful if we do. What is the greatest common factor for that, Ian? 2. So we're going to divide everything by 2, pull it out here, and then we'll have 3x squared minus 5x minus 2. Okay. All right, so the 2 just kind of hangs out front. Or technically you can divide the 2 off and it'll go away because 0 divided by 2 is 2, but we'll just leave it there for right now. And then we are going to factor this further, like we have been doing, right? Keep that equals 0 there on the side. To get 3x squared only options are 3x and x. Caitlin, what are our options for our negative 2 there on the end? It's really about it, except for we could do negative 1 times positive 2, right? Switch where the negative's at. You don't have to list it if you don't want. So what we're going to do is we're going to guess, because we don't know, especially when we've got this 3x right here in front, right? Neither one of those are going to give us 5, because we got that 3 right there. So if I put a plus 1 minus 2, it is really important here that we check it. So when we multiply it back, Caitlin, what will we get there? Then what we get next? Very good. Right here. And then for the last, negative 2. Is that what we want to get? These two right here combined to give you negative 5x. That is what you're supposed to have up here. So we actually picked the right ones in the first go. Sometimes, a lot of times you don't. So if we didn't, we would maybe switch where the numbers are at and try again. But it worked. So, all right, questions so far? We're good factoring. All right, now we are going to use the zero product property, which is the magic that says that 0 times anything equals 0. So that means if any of this equals 0, then the whole thing is going to equal 0. So, we do have this 2 out front. So we could set 2 equal to 0, but does that do anything? Does 2 ever equal 0? No, you don't really get an answer from that because it doesn't have a variable with it. If it had an x with it, then you could get an answer, but you don't get anything from just that. We also are going to have 3x plus 1. If it equals 0, the whole thing is going to be 0. So to solve this, Giancarlo, what would I do to solve this? Good. 3x will equal negative 1, and then what will I get, Giancarlo? Good. We'll divide by 3, and we'll get negative 1/3. So that's one of our answers. And then the last one is this x minus 2 equals 0. And again, if you want to do this part in your head, it's fine with me if you don't write this, because you're just picking the opposite number here. You'll get x equals 2 for that. So we got negative 1/3 and positive 2. Okay, everybody good there? All right, here's a couple more. Oh, I need to do one more kind of problem too. I'm going to have to add an example 9 because I did not do one that we should have done. All right, so, oh, never mind. Never mind, I did put it on here. I did put it on here. Okay, I was thinking this was my last slide for some reason. All right, so we've got 3x squared minus 12x minus 12 equals 3 minus x squared. So this has to equal 0 before you can do anything with it, and it does not currently equal 0. So I would suggest trying to make sure your x squared is positive. Things are easier to factor if your x squared is positive. So I would take this x squared right here and add it to the x squared over here to get rid of the x squared. And I take this 3 and subtract it. So that would give me 4x squared minus 12x minus 15. And nothing is left over here. Everything canceled out, so that's equal to 0. Which is what we need, because if we don't have an equal 0, we can't do the problem. Is there a greatest common factor for this one? No, it kind of feels like there should be like 4 or 3, but there's nothing that goes into all 3 of those numbers. So no greatest common factor, which means for my first term, I got 4x squared. I could either use 2x and 2x, or 4x and 1x. Those are my options there. Then for my last term, I've got negative 15. So I could use negative 5 and 3, or negative 1 and 15, or I could switch the equal sign, or the negative signs. So we're just going to have to play around with it a little bit here. Anya, which ones do you want to try? All right, so we're going to do 4x here and x here. And what do you want to try for the last terms? All right, let's try negative 5 and positive 3. So if we test this, this will give us 4x squared plus 12x minus 5x minus 15. Is that going to work? No, if we get a positive 7, we're looking for a negative 12 there. So, before we give up on those terms, let's try switching the 5 and the 3. So let's put the, I forgot where they were at. Let's put the 3 here and the 5 here. Not going to work either. So, we'll get 4x squared. Then we'll get plus 20x. We'll get minus 3x minus 15. Does that work? Does not. So that one's not going to work either. So 3 and 5 does not work, at least with 4x and x. Anybody found what works yet? This one's got a lot of options. Okay. Let's see. You said x plus 15. No, x plus 15. That goes here. And minus 1 here. No, other way. 15 here. 1 here. I think it's going to be close, but I don't think it's going to quite work, because here we'll get negative 15x. Here we'll get positive 4x. That gives us a negative 11. It's close. It's almost there, but it's not. I'm thinking switching it's not going to work. I think we got to go to the 2x's instead of the 4x and the 1x. So let's go back and try again. So let's try 2x and 2x. And then let's do, what do you guys think? I don't think 15 and 1 is going to work. Let's try the 5 and 3. Minus 5 plus 3. Okay. To shortcut this a little bit, instead of multiplying the whole thing, you can just check your inner terms, negative 10x, your outer terms, plus 6x. Does that work? No. I hope I didn't make a bad problem. Has anybody got one that'll work?
I don't think it would work.
Let's see. 3 here. Wait, is that where I just had them? I made a bad problem. Starting to look like it, isn't it? You guys want to see something cool? You want to see a band calculator that you cannot use under any circumstances in my class? This is TI-89, 4x squared minus 12x minus 15. Factor. It does not factor. I've made a bad problem. Let's make this, let's see. Let's make this, well, let's make this an 11. We got that to work with an 11. Let's make that an 11. So change the problem, because I made a bad problem. No wonder we couldn't figure it out. Make that an 11. We got 11 a minute ago, didn't we? with a 15 and a 1. So we had a 4x and an x and a minus 15 here and a plus 1 here, I think. So let's make that an 11. Sorry about that, guys. There should not be any problems where that happens, where you can't factor, because for your class, you're only required to learn to solve by factoring. There is other ways to solve that. Quadratic formula, complete the square, other stuff. You'll learn those in math too. But everything should factor. So if there is something that won't factor, probably you're just not like seeing the one that'll factor, or there's a chance that it's a bad problem. Particularly if it's a worksheet I made, there's a higher probability it might be a bad problem. The worksheets and the Delta Math and stuff are usually a little better. Alright, so, alright, this works because we're getting negative 15x and positive 4x, which gives you negative 11x. So, what we've got is we've got 4x minus 15 times x plus 1 equals 0. You got to be careful not to give that as your answer. That's not your answer. When you're asked to solve, you should be getting answers like x equals 2 or x equals 1/3 or something like that. So for each one of these, we're using the zero product property. 0 times anything equals 0. So 4x minus 15 will equal 0. And x plus 1 will equal 0. So if we solve each one, if I add the 15 here, 4x equals 15. I divide by 4. X equals, that doesn't go evenly, so I'm just gonna leave it 15 over 4 for that one. And over here, I get x equals negative 1. Want to see another reason why you can't use this calculator? Watch this. Watch this. It'll do everything for you. It'll solve equations. It'll solve crazy equations. I could ask it to solve, I could ask it to solve 8 to the x power plus 2 to the x power equals 130. And it would tell me the answer is natural log of 5 divided by natural log of 2. Or if you hit the green button and enter, it'll give you a decimal for it. It takes it a while to do that sometimes. But you must master solving equations by hand before you can be trusted with this. My calculus class has these. They use them. You cannot use these on the ACT. You cannot use them on any EOC tests. But you can use them on the calculus exam. I may have broken it, though. This happens sometimes. Sometimes I tell it to solve things and it freezes up and won't work anymore, and you have to take the batteries out. No, there it went. It just took a long time. So, they're pretty cool. Alright. Yeah. Kid, they cost about $150, maybe $200 now. Pretty expensive, but some of your teachers will probably not let you use them, depending on what course you are taking. If you are taking, like they told us, if you're taking upper level math, if you're taking your calculus and that stuff beyond, they usually wanted you to have one of those calculators. I know that's what I used all through college myself, but for some of the lower level courses, you might not be allowed to use them, depending on your professor. Yes? You will not need them today. Everything that you get should factor. So, the stuff that you ran into yesterday that would not factor, like when you take your quiz on this tomorrow, you will have a calculator, but it's only for those ones where you were having like a square root of something. So any of these problems that have an x squared and an x, they should factor. And if they do not, it's because I made a bad problem. But hopefully you won't run into any of those. I redid these notes and obviously did not check over them carefully enough. All right, let's try the next one. Makes me nervous now. This is not like super easy to factor right here. Okay, I've got 9x squared minus 9x minus 10 equals 0. I need to factor it. My first term is 9x squared, which could be 3x times 3x, or 9x times 1x. And then my last term is negative 10, which is either going to be negative 2 and 5, or negative 1 and 10. You got it already, Aiden? What'd you get? Negative 10, positive 1. Let's check it, make sure Aiden's got it. That's going to give me, that's going to give you negative 30 plus 3x. Yeah. So we've always got to check. Alright, Savannah said negative 5, positive 2. Okay, and just like the factoring problems that you've done, sometimes they can get a little frustrating trying to get the right ones. So we got negative 15x, positive 6x. That does give us negative 9x, so that works. But remember, that's not your answer. You're not done yet. So you're going to have to do 3x minus 5 could equal 0, or 3x plus 2 could equal 0. Alright, so once you get it factored, you're going to set each one equal to 0, and then you're going to solve those equations. And they should be pretty simple two-step equations or less. Divided by 3. So right here we're going to get x equals 5/3. Right here, x will equal negative 2/3 here. And because you will have your calculator on the test tomorrow, on the quiz tomorrow, not test, quiz, you can check your answers by plugging this in. So like if I get these two answers, if I do 9 times, let me go back and get your calculator, not the, because it does things a little bit differently. 9 times 5/3 to the second minus 9 times 5/3 minus 10. It equals 0, so that works. And then you can check your negative 2/3. So if you want to check your answers, you can. Okay, questions? Alright, we got a couple more. And so these two are going to be easier than a lot of the other questions, but they will throw you off sometimes. Yes? Like, he was like 8 minutes late or something. Ruined a streak. I think he lost his keys. I think is what he said. He spent 30 minutes looking for his keys, I think. So he was up to like 16 and ruined it. She was not here today. She's in Europe. So, my Raven Poindexter. My first period class, some of the students in my first period class like to turn anything into a competition. You should have seen the spreadsheets they had for pickleball a while back. They had rankings. Who was top out of everybody. Can be. Sometimes you can go a little overboard.
Not nuclear warfare.
Yeah, but I mean it's positive, you know. It's positive competition there because we want everybody to be here on time, which they're usually on time except for sometimes Connor. He cuts it close a lot of time. Yeah. The train gets him sometimes, though. He lives over in Jonesville, so. All right, so. Yeah. Yeah, Yeah. One of the answers is 3, but it's not the only answer. Okay? Actually, yeah, 3 is one of the answers. But there is another answer. Okay, so these two are going to be easier than a lot of the other problems, but a lot of times they throw people off. Okay, so any ideas on how to do number 9? Not the answer, but how to do it. Okay, we could do a greatest common factor. What can you pull out? So I got 6 times x squared, if we're dividing everything by 6. We get 9 there, okay? From here, what do we do? We got to factor again. And this is one of those special cases where that middle term went away. So I'll have to have x and x here. What will I have? Minus 3 and plus 3. Okay? And then, zero product property. I said everything equal to 0, right? 0 times anything gives us 0. So 6 equaling 0. Do you get anything from that? No. X minus 3 equals 0. If we add our 3 here, that gives us x equals positive 3. And x plus 3 equals 0. If we subtract our 3, x equals negative 3. Okay? This will work on most problems that you are going to see. It is not the only way to do the problem. You could have done this one yesterday because this one does not have an x squared and an x, right? So this is a perfectly valid way to solve this problem and it will work, but you could have done it like we did yesterday because this one only has an x squared. It doesn't have an x squared and an x. So you could have added 54. 6x squared equals 54. You could divide both sides by 6. So x squared equals 9. And then you could square root both sides. So x would equal plus or minus 3, which is the same answer that you get over here with the other method. It really doesn't matter which way you use. Either one is fine. The only thing I will say is that if you've got one that's not going to be whole numbers, if it's going to be like a square root of 7 or something, you have to do it this way because it won't factor if you have something that won't factor over here. But most everything you should run into will factor, so you could do it either way. Okay, questions on that one? Sometimes it throws students off that that middle term is missing, but you know how to deal with it. All right, what about 10? When, yeah, it's not very complicated. Actually, I want to ask Aiden a question first. How did you get that it was going to be 3? Okay, so you were just kind of plugging in, guessing, checking. Okay. I was going to see, does anybody else, before I let Evan go with his what we should do, no, it won't be negative 3. Negative 3 squared does not equal 3 times negative 3. It's going to be positive 3, and there's another answer. Does anybody else have any idea of something you think might could happen before I let Evan try what he was going to say? It's going to be wrong, probably. But like an idea that you think maybe you should try. Nobody wants to say it because I just said it's going to be wrong. But one thing I sometimes see students try is they like divide both sides by x. And so x squared divided by x is just x. You took an x away, and then you get 3. It will give you one of the answers, but if you ever divide both sides by x, you're going to lose an answer. Okay? So this is not something that you want to do. It'll get you one of the right answers, but it won't get you both answers. So you don't want to do that. Instead, Evan, what were you going to say? What should we do? Okay? So x squared minus 3x, because it will become a minus when we move it over to the left side. It will equal 0 because there's nothing left on the right side. No, don't add a 0. I think Caleb taught you to do that maybe, but don't do it. If you find yourself adding a 0, there's a better way. What do we always look for first? Greatest common factor. Does this have a greatest common factor? X. So pull out an x. So if we divide both of these by x, we will get x times x minus 3. Okay, so if you see that you're missing that last term, it's going to be a greatest common factor problem. Then you're just going to set each one of these equal to 0 because this is multiplied right here. Anything 0 times anything is going to be 0. So x could equal 0, or x minus 3 could equal 0, which will give us that x equals 3. So 0 is also an answer. All right, questions? All right, but so I don't forget, let me give you a glance at your quiz for tomorrow. I'm not going to be here tomorrow because I have to take Henry to the dentist. I'll be here in the morning. If you need to come by for smart breakfast, I'll be here. I'll be here until about 1 o'clock when I have to go pick him up and take him to the dentist. But I will not be here for your class. So, your assignment tonight is going to be a worksheet. Ms. Hendrick is going to be here. She is going to go over that worksheet with you if you have any questions. And then you are going to do, let me find it. There's going to be a practice quiz for you that you're going to do in class. And so if I hit preview here, I'll show you what it's going to look like. The practice quiz is just going to have 8 questions similar to what you're going to see. And so what I have done for this question, this problem, is I have made them multiple choice, but as you can see, there are lots of choices, and there's probably on these more than one answer. There might be a few that only have one answer, because sometimes you end up getting something like x minus 2 times x minus 2, where you got 2 answers, but they're the same. But most of these are going to have 2 answers. And so this will let you select more than one answer. So this is a pretty easy problem, x squared equals 144. What would we do to that problem? Square root both sides. Square root of 144 is 12. So I would pick 12. What else would I pick? Negative 12. So you'll pick 2 answers. Now it is possible for you to go through and just plug in answers on all this and see which works. But I have put so many answer choices that it is going to take you a very long time to do that, and you will not finish the quiz on time, and you have to finish the quiz on time. Okay? So you need to be actually trying to solve these, not just plugging in answers. Now you can plug them in to check to see if they work, but if you're just plugging in, it's going to take you too long, right? So like if on the next problem, I just get out my calculator and start doing negative 4 squared minus 8 and see if I get, oh, that didn't work. And then I try the next one, the next one, the next one, the next one. You're just not going to finish on time if you do that for every problem, because some of these have so many answer choices and some of them are decimals, and you're just going to have trouble if you do that. So not every one of these has 2 answers, but most of them have 2 answers. So for most of them, you should be choosing 2 answers on these. And so it's just going to be a bunch of solving problems. A lot of them are going to have an x squared and an x. So you will need to factor, move everything to one side and factor like we did today. Some of them are going to be like the very first problems we did that are already factored. Sorry, factored. What are the answers to that one? Positive 3 and negative 5, right? So if it's already factored, the work's practically done for you, right? Don't try to multiply it back or anything. These problems are like yesterday's problems. There is only a single x. There's not an x squared and an x for that. So subtract the 5, divide by 2, those sort of things. Okay, so you'll see some of those both. All right, so this is what the practice quiz looks like. I think the actual quiz is the same, except for it may have 10 problems instead of 8. Yes, but I will instruct her to tell you like probably like 45 minutes before class is over, if you haven't finished the practice quiz, quit and go ahead and work on the actual quiz so you got enough time. Yeah, the actual quiz has 10 questions, so it's got a few extra questions, but it's just very similar to what you'll see that tomorrow. If you want to, you can do the practice quiz tonight, but I want you to like take it again in class tomorrow. So if you want to go ahead and make sure you got plenty of time to think about it and try it, you can do that practice quiz tonight and then do it again in class tomorrow, because it should let you take it as much as you want. I need to make this work. You can't see the answers on the actual test. I need to put the due date also, so for that. So that's what you're looking at tomorrow. So you'll come in, go over the homework, and then you'll do practice quiz and the quiz. There might be something for you to look at after I. So our homework here, this worksheet. Haley and Blake, when you guys want to work on your test right now instead of in this homework, and that way you won't have as much to do in the morning. I'm going to send you back over here to the it's not as many as it looks like. It's not front and back. I copied it wrong.